So the next we would like to solve a problem based upon interpolation method. So this type of problem or the method will arise in the design of gears as well as in case of the design of belts. So this method here, it says that the oilness curve for a 75 mm into 125 mm long bearing happens to be a straight line passing through points 191. This is the bearing modulus 191 into 10 power minus 9, and mu is equal to 0.002, and another point is given. That means for 191 into 10 power minus 9, it is mu value is 0.002, and for 956 into 10 power minus 9, it is 0.0065. These two points, when they pass, it seems to be a straight line. And our data, whatever they have given, is for the problem the load supported by the bearing is given, that is W, speed is given. We need to calculate the frictional loss, and the operating temperature is also given, and the viscosity is also given. So now we also need to calculate what is the bearing characteristic number for this particular problem, for the particular data. So for that, S double dash is equal to nu n dash by P. Nu is given 8.7 centipies 10 power minus 3. N dash is n by 60, that is 20. P is nothing the bearing pressure, that means W divided by L into D. W is nothing but it is the load divided by projected area. So once we calculate, S double dash is equal to 326.25 into 10 power minus 9. So understand this one very clearly. One point is 191 into 10 power minus 9. For this it is 0.002, and for the 956 it is 0.0065, but our data is not in between these two to take the average of 0.002 plus 0.0065 divided by 2. It is not exactly at the center, but it lies somewhere in the on that particular line. For that, interpolation method is required. So here the interpolation method can be understood with this particular sketch. So for bearing modulus of 191 into 10 power minus 9, it is 0.002, and for the 956 it is 0.0065. Our data, whatever we have calculated, is 326. It does not lie exactly at the center, but for calculations we have shown it here like this. So what is the required value? So for this we have this is a straight line. This is a straight line which they have explained. So up to here is the value called as 0.002, but we need to calculate for the mu value for 326.25. To calculate that, we can say that for 326.25 into 10 power minus 9, the mu value is 0.002 plus x. So to understand this, we have considered this equation: x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1. Here x is nothing but the bearing modulus of the at the initial state, that is the lower value 191. x1 is the lower value, x2 is the higher value, and x is the value which we have calculated for that y is required, right? So x1, for the particular x1, y1 is the mu value, for the x2, y2 is the mu value. To calculate this, once we substitute x minus x1 is this one, x minus x1, and correct, divided by x minus x1 divided by x2 minus x1 is equal to y minus y1. Y minus y1 is nothing but x. So that is what here they have given x, and y2 minus y1 is this. So now we go after substituting and calculating, we get x is equal to this. This x we have calculated, but we should not forget that it has to be added with 0.002. So mu is equal to 0.002 plus x value for 326.25 into 10 power minus 9 bearing modulus. So we have determined mu value, and once we substitute in this power loss equation, we can calculate, we can get 0.079 kilowatt. So this is how we do it by interpolation method. So, and there is one more problem also which I feel that it is very important, and here oil ring full journal bearing is to operate in still air. The bearing diameter is given and the length is also given. The bearing is subjected to a load of 5 kN and it rotates at 500 revolutions per minute RPM. Radial clearance is given. This has to be very much understood. Radial clearance is 0.0625 mm. As it is mentioned in the mm, it is C dash radial clearance. If they say that it is just clearance, then it would have been the radius without any unit, because psi, it is psi. The oil is SAE 30 and the ambient temperature is given. You need to calculate or determine the equilibrium temperature and the viscosity of the particular oil. So understand this one very clearly. Equilibrium temperature means at which heat dissipated, heat generated and heat dissipated should be zero. That is called as equilibrium temperature. So in order to calculate that, first you need to calculate heat generated and heat dissipated for a particular data. So for this they have given, we calculate heat generated by this formula. Hg is equal to mu into W into V. Mu is by Mackey's equation, W is the load and U is the velocity. So these calculations are with respect to the mu values, for that is by Mackey's equation. Once you substitute, we are not getting a rounded value. Instead we get it as 0.10967 into psi plus 0.002. So this is because we don't know the viscosity, because they have mentioned it as in a problem it is SAE 30 and the ambient temperature is given. Ambient temperature is 20, but we don't know what is operating temperature. So here to calculate, we are trying to vary the operating temperature by taking three different trials. One is either you can start from 60, 70, 80, 90 in that way. So in this problem they have taken it as the operating temperature as 70 degrees. Once they have taken it as 70. So from figure 24.2 for oil F at T0, we got it as viscosity is equal to 22.5 centipoise. We have substituted this, we get mu value, and also we have calculated heat generated. Heat dissipated is also calculated for the particular trial of 70 degrees Celsius. So C we are supposed to calculate, A also 25. So 70 minus 20 divided by 2, we got heat generated also. So heat generated and heat dissipated, we are trying to get two values, and that is being plotted here. So for 70 degrees this is heat dissipated and this is heat generated. Similarly for 80 degrees we are trying to calculate, we got two values, and similarly for 90 degrees also. So you need to calculate 3 or 4 trials also, such that there should be there should be a cross line crossing between the cross line between or the. So here we need to consider at least 3 or 4 trials such that an equilibrium temperature is reached. Here the equilibrium temperature means where the heat dissipated and heat generated pass against each other, where we get one equilibrium point. That means here is the point where the two lines cross, that is the two data lines cross against each other, and the corresponding temperature is 77.5. At particular 77.5 temperature, heat generated and heat dissipated is 0. Corresponding to this temperature, we once again need to calculate the viscosity for that particular grade of the oil, and that is being given as for F grade oil at particular equilibrium temperature, they have determined viscosity is equal to 18 centipoise.